Hello, everyone, and welcome to today's webinar. The topic is leveraging advanced AI models for attribution. My name is Ravi Peravali, and I head up our media practice. And presenting along with me is Atul Varshneya, who heads up our AI ML practice. So, we are going through before I go there, just some housekeeping tasks. If you have any questions for us during the webinar, please post them in the chat window on the right-hand side. So we are going through some trying and challenging times. Our customers, their businesses are drastically changing, and the business environment is changing. Their expectations from the businesses have changed. And there's no other industry that's more adversely impacted than the advertising and marketing industry. Marketers are under tremendous pressure, as we're all aware of, because of the cost cut in budgets, to really start looking at the ROI from all of their campaigns and cut down on the budgets. So for this reason, we thought this topic of multi-touch attribution would be opportune. So before we get into the advanced models, I wanted to spend a couple of minutes talking about defining multi-touch attribution, so that we are all on set a level playing ground in terms of its definition. So let's take, for example, Jay. So she interacts with a brand in various ways. She may interact with it on the web, through social media. While driving, she may hear an ad related to the brand. There are the digital billboards. So she goes through a journey before she converts either to a online purchase or in-store purchase. And right now, if you look at the number of channels through which Jane can be engaged with a brand, it's actually increasing everfold. Now, you have digital out-of-home advertising, which probably, given the circumstances, is not growing as rapidly. But in-game advertising, for example, has become a big component of how especially millennials are engaging. So the problem so what does multi-touch attribution do? What it does is looks at all these touch points with J and attributes a credit or score to each of the touch points. So let's talk a little bit about some of the models that are used currently to measure each of these interactions that Jane has. So if you look at the first two on the left-hand side, there's what's called the last ad and first ad. So what these models do is they give the entire score or credit to either the last touch point that Jane had with a brand or the first touch point. So these are very simplistic. What they do is they eliminate all the other touch points from Jane's journey. So as we all know that in order to for a conversion to happen, that all of a multitude of touch points are needed. So the next three models look at distributing the score across these various touch points. The linear, as depicted, gives equal credit to each of the touch points. The position-based gives the maximum to the first and last, and then distributes the score evenly across the rest of them. And finally, time decay is sort of temporal in the sense that it looks at the last touch points and gives it the maximum, and then sort of descends based on the temporal interaction. So all of these models, as you can see, are very simplistic and really not data-driven, number one. And number two is they don't take into account the multitude of journeys that customers have had. So the final model is what I call custom model, which is really using algorithmic and AI ML models and very data driven. So at Tavant, for the last couple of years, Atul and his team have been working with a number of our customers in analyzing their data and coming up with what we believe are very compelling models for assigning credit to these various touch points. With that, we'll dive into the meat of the discussion, where Atul will discuss the various models. Atul?
Thank you, Ravi. Hello, everyone. So as Ravi said, I'll talk more about the models. But before I get started, just wanted to give you a sense of where the industry is today. And for that, I'm showing you two surveys that some market analysts have done. So on the left-hand side, the survey was about a question: which attribution model does your marketing team use to measure performance? There were about 350 companies that were asked this question, and the results are plotted here. As you notice that at the time of the survey, little more than half were still using the one-touch attribution kind of models, and slightly less than half were using multi-touch. But in there also there was all the three flavors that I mentioned here: multi-touch, which are linear, weighted, and also custom. Custom are basically algorithmic and model-based, data-based methods. So, however, the balance of the split between single touch and multi-touch has been like this. The right-hand side survey actually shows that the confidence that people have on the multi-touch attribution methods is much higher compared to the single touch methods. And that is where the industry seems to be going. That's where people are looking for newer solutions, and hopefully there'll be a higher adoption of this as time comes. So today I will talk about 4 methods in the algorithmic and statistical approach category. And here my approach is to provide, because of the short time that we have, in this webinar, my aim is to provide key ideas behind each of these approaches and talk at a level to develop an intuition about how these work. I will not get into the various nuances and finer details of these talks because of the time limitation, but if there's any interest, please feel free to contact Ravi or me. We'll share our contact details at the end of the talk. So these are the 4 that I'm going to talk about: logistic regression, Shapley, and then the 2 Markov modeling-based approaches, Markov chains and hidden Markov model. So before I get to the actual approaches, let me just talk about the kind of data. And here again, I want to give you a sense of what kind of data is actually required for doing these kind of modeling. So the key characteristic of the data are twofold. One is that we need to capture all the events that indicates the customer's interaction with the touch points. So basically, and also the sequence in which they occur. So basically, all the channels, all the touch points that the customer went through, and then finally the information about whether all that led to a conversion or not conversion. So these are the 2 key elements of the data that needs to be captured. And a lot of such data that's being captured is of clickstream, of online, but there are also non-addressable channels that this data is also captured. But just taking an example of clickstream data, the clicks that were made on the site and where they came from, those kind of information needs to be captured. In some instances, since we're talking about clickstream data, in some instances, clickstream data can also be used to infer information about non-addressable channels. For instance, a search during or right after a television ad was broadcast can indicate with reasonable degree of certainty that the person actually watched that advertisement. So such kind of side benefits can also be reached, or such kind of inferential way of coming up with information about the channel interactions can also be captured in the data. Now, in very simple terms, I want to show you what the data should look like. And this is more to give you a mental map of what would that data actually look like at an abstract way. So the path information, which basically, for instance, here we show moving from website to website, or moving from some magazine to some website to some radio ad, some news site, and so on. So the path, the sequence in which the customer goes through various touch points, and then finally, does that lead to conversion or not? So various people who go through each of such kind of journeys, what is the kind of conversions that you're seeing when those journeys are there? So this is just a simple illustrative example of the kind of data, but it gives you the sense of what kind of data needs to be captured for doing these kind of modeling. Okay, so let's start with the very first method among these modeling techniques. So logistic regression, it's a very well used, very traditional statistical method for classification. Basically what it does is it takes inputs of some data and then comes up with a prediction of what class that input data should belong into. So you could think of taking inputs, taking some features about some product and coming up with whether that product belongs to a certain category or not. So the way it works is by taking each of the elements of the input, multiplying it with some weights, running some nonlinear function on it like this, and which basically comes up with the probability calculation of something belonging to a class or not belonging to that class. This is the way the logistic regression works, and for this model to work, it needs to be trained, and it is trained on a lot of data which has the inputs and the expected output of that classification. Using those, the training method comes up with the weights. And now you can imagine that each of these weights indicates the importance of each of those elements of the input data. If theta 1, for instance, is very high, then the impact of this variable will be of x1 will be significant on making a judgment whether the output belongs to a certain class or not. But if the value of theta is very small, think of it in the extreme case like 0, then this will have absolutely no effect. So the smaller the value, the lesser the importance, the higher the value, the higher the importance. And that basically correlates with the idea of attribution. So if we use the concept of logistic regression of classification, but use the touch points as the input data, and the label, the output being the classification being conversion or no conversion, then using the touch points input and the conversion labels, we can train the model, and the value of the weights that we come up with will give you the indication of the attribution for each of those touch points or each of those channels. So how do you use it? So each touch point or campaign or ad becomes one of the variables, and the conversion, whether it got converted, whether the journey involving those touch points finally led to conversion or not. And then you train a logistic regression model to predict the conversion based on the historical data. So for all the journeys, you take all the touch points and the label of conversion or not conversion, and then you basically train the model to make those predictions to a reasonable degree of accuracy. And then the weights that you get here for each of the touch points gives you the attribution of each of those touch points from the point of view of multi-touch attribution modeling. Now, so basically this is converting the attribution problem to a feature importance problem in the machine learning domain. Now, all of us have heard of many more sophisticated techniques than logistic regression for doing classification, like deep learning. The only issue with those techniques is that the interpretation of the weights there is not so straightforward with respect to attribution. Those models are generally opaque, and it's difficult to interpret the meaning of the weights that you come up with respect to the importance of each of the touch points. Therefore, logistic regression, even though does not have that high degree of accuracy but it's very useful in coming up with the attribution weights or the attribution for the various channels or campaigns or ads. So this is the first model which is generally used. It's functional, it does its job. But the other model that I want to talk about is Shapley Value. Now this model is based on the game theoretic approach. Here the core idea is that you think of a team of players, think of like a basketball team or something. And the idea is to see that when you add a player to the team or you take that player out of the team, how much are you impacting the capability of that team to win, or the performance? How does it affect the performance of that team? So the way it works is that it takes the rest of the team minus the player in question and then evaluates the cases where the player was part of the team and the cases where the player was not part of the team, and sees how that had impacted the overall performance of the team. Now, the team itself could have been formed by various permutations, because we're considering adding a player at a time. So in the sequence in which the players could have been added to the team could be various permutations, and therefore the value of the player, of the new player added into the team, is averaged over all the possible permutations of that, of the way the team was formed before this new player was added. That is the key idea behind Shapley values. So in simple terms, given the payoff from various coalitions of players or channels in our case, a fair way of gains distribution or attribution to the individual players or channels. That is the core idea behind this. So it basically treats this channel as a player cooperating with other channels to win the game, which is to get the customer to convert. And based on the measure of winning, you want to give an attribution to individual players. All right. So this Shapley value, by the way, is a very popular and very effective method for the thing that I mentioned earlier of feature importance calculation. So in machine learning, it is used very often where you want to find out which features were very important for computing certain result. The output of the machine learning model, how is it getting impacted by the various input fields? Their Shapley value turns out to be very, very effective. In fact, one of the most popular, very popular ways of computing that importance. And that kind of flows from the previous idea, where in logistic regression, we were using the very simple way of coming up with the importance of the features and therefore attribution, while Shapley value does a better job, and therefore that's the reason why it is very popular in the machine learning space also. So Shapley value, coming from game theoretic methods, computes the attribution when it treats individual channels like players in a team. The third model I want to talk about is a Markov model. Now, if you saw in the previous two models, the logistic regression and the Shapley value, there was no concept of sequence in which the customer went through the journey. However, in Markov models, we take care of the sequence aspects also. So this particular modeling method relies on how the different journeys indicate the probability of a customer going from or transitioning from one channel to the other channel. In other words, what is the likelihood that if a customer was exposed to some marketing tactic, be it email, be it some online ad, be it a television ad or whatever, what is the next likely step and what's the probability of that person transitioning from that to the next channel or to the next exposure of the marketing tactic. So those represent states in the Markov chain, and the transition from one to the other is captured as the probability of those transitions. So state is interaction with a channel, and transition is the probability of going to the next one. Let's take an example to illustrate this point. So supposing we have our path and conversion data with this kind of information. We're taking a very small set for illustrating the idea that from the starting point, the person moves on to, let's say, Google Ads, with leading to 2 conversions, or from starting point gets a mailing campaign, leads to 1 conversion. The other is starting from the starting point, moves to Google Ads, receives a mail campaign email, which leads to 1 conversion. And in some cases, the journey goes from start to Google Ads without any conversion. So supposing these were the only 4 that we're talking about, there will obviously be millions of such entries, but we are just taking these 4 for an example. Now, from these, you can see that from Google Ads, there were 4 possible transitions to conversion, to mailing, or to null. And similarly, from mailing to conversion, there was just 1 transition from mailing. Similarly, from starting point to Google Ads and starting point to mail, there were 2 transitions from the starting point. So based on this, we can come up that from starting, the probability of going to Google Ads is 80%, going to mailing campaign is 20%. From Google Ads to going to mailing is about 25% probability, going to conversion is 50% probability, and going to no conversion is another 25% probability. That's basically, so this is how you construct the transition, the state transition graph in Markov chains. Now, what do we do with this graph? Through this graph, you can actually find all possible paths from starting point to conversion, and then traversing those paths, you can multiply the probability of making that transition to give you the overall probability of going from starting point through that path to conversion. And then you can add up such kind of probability across all the paths that lead from start to conversion to come up with the overall probability of conversion happening by looking at all the paths and their probability of actually leading to conversion. So in this particular example, we see 3 paths which lead to conversion, and the overall conversion probability in this particular small toy graph is 80%. Now what we do is we take away one of the channels and see what effect does it have on the conversion. So when we take Google Ads, we're left with only this graph, which leads to a conversion probability of only 0.2. So it changes from 0.8 to 0.2. Therefore, the actual attribution turns out to be 0.75, which is 0.8 minus 0.2, which is 0.6, divided by 0.8. The other one is when we take mailing out of the mix, then the only path left is this, and based on that we can compute the mailing the attribution for the mailing time. So this is how Markov models are used to compute the overall attribution for individual channels by using what is called the removal effect. The removal effect is to remove a channel from the graph and look at the change in the probability of conversion to come up with how much impact did that channel have in bringing up the conversion from where it was not there to while it was there in the mix. So this is how the Markov model works. The final model I want to talk about today is hidden Markov model, and it is ironic that I will not be able to spend too much time on this, but this happens to be the most important model in my mind because the way it works. The core idea behind hidden Markov models is that it is trying to determine what is the state of mind of the customer, of the consumer, based on the various observations of the visible things that this model can actually work on. So the actual mental state with respect to whether the customer is engaged with respect to making that purchase, is actively looking for information about the product, or those kind of mental states are hidden. Those cannot be directly observed. But what can be observed are the various actions that that individual is doing. For instance, clicking on the website, so doing a search, or actually making a purchase. Those kind of actions are visible, and using those, one can determine what state the person could have been in, and that's what is the core idea behind hidden Markov models, because it's looking at what are the actual states in which the customer can be at a given time, and that's where its power comes in my mind. in my point of view. The various states that this model uses can be different based on how you want to model it. And so various different ways of modeling it include states such as this set of states, which is disengaged, active, engaged, and converted, which I've shown in the chart over here. Some of them keep it much simpler by keeping only 2 states other than conversion, which is investigating and ready to purchase. Or there are some other states which can be derivatives of the typical IDA model, attention, interest, desire, and action. So it can be some derivative of that kind of modeling. So you decide on the kind of states that you want to follow, and then you build a modeling, hidden Markov modeling. So in my view, what makes it really useful is that this technique attempts to model what would be happening behind the scenes using the observations that are accessible. And in broad terms, the methodology involves the following. It uses the historical data in which each event, because we have access to the events past and events future, so we have both the information about the event. It uses that data to compute the state transition probabilities, means what is the inherent way in which the states transition, what is the probability of being in a state at any given time, and along with this, the use of concept of posterior probabilities to tease out the contribution of various channels, how they make those transitions possible, and what is the impact of exposing to a channel which causes the person to move along the conversion funnel. So this, in brief, is the idea behind hidden Markov model. Just to mention that hidden Markov models have been extremely successful in machine learning space. They have been very, very effectively used for a number of use cases such as speech recognition, writing recognition. They've also been used in the area of object or face detection, and a lot of areas of natural language processing. All of those things have in common that you're trying to determine what is not directly observed, but you're trying to infer what could be happening behind the scenes. And that is, in my opinion, the reason why this brings the maximum kind of value as compared to the other modeling techniques. So these are the 4 that I wanted to cover today. And now we are moving to questions and answer session. We have a few minutes left. Ravi?
Yeah, thanks, Atul. So I think we have time for a couple of questions. So Atul, if you can take this one. So you've discussed 4 models. So in terms of practical usage, if I'm a marketer, how do I determine which of these models should be used? Are there some broad guidelines for selection of models?
Yeah, that's a good question. So among the ones that I spoke about today, the Markov models with online data, if you use Shapley or Markov models on top of the online data, then I would say that's the fastest and easiest to implement. They can be very quickly implemented, and they provide reasonably robust analysis, which is very practically useful. But as I was mentioning, hidden Markov models is a very powerful method. And as I had mentioned earlier also, it has been used in many other areas and has been extremely successful there. It definitely is somewhat more involved than most other approaches. But the results that are obtained from this kind of modeling technique have been seen to be much more intuitive, and they make a lot of sense to the marketers themselves. So in my opinion, that would be one to go with for most effective analysis of the attribution problem. One more point I would like to very quickly highlight is that, and that I had kind of touched upon while I was talking about the modeling techniques, that logistic regression and Shapley, these two treat the channels in the journey, in the customer's journey, as an unordered set. Basically, they ignore the idea of sequence in which they appeared in the journey. So from an intuitive perspective, you can actually see that that this kind of information is not exploited by the logistic regression and Shapley methods. gives you a sense that the information that they're using is better. So that's another reason for us to get the intuition that those should provide better performance.
Absolutely. We are a little over time. I think I'll take one more question here. So this is a good question, and I'll briefly talk about it. The question is, once the credit has been determined using these models, how do I leverage this? So I'll take that, Atul. So if you look at, there is this concept of media mix optimization. So what media mix optimization is basically an optimization problem where it takes your dollars available for a campaign, looks across all of your marketing channels, and tries to optimize how to spend across each of these is. So think about it. You as a marketer are probably using some heuristics based on your experience or based on one of the simple models that we discussed earlier. But what this will allow you to do is now take these values, plug them into the media mix models so that your campaign dollars can then be shifted appropriately. So that's a high level concept, and obviously there's a lot more details that we can discuss. So with that, we'll wrap it up. We did not get to a number of questions, which we'll get back to you on. And again, I think the idea here was to present these models at a conceptual level and give an understanding of how they work and the differences. So if you have any questions, please feel free to reach out to Atul or myself. Our email addresses are below. Thank you again for joining, and say goodbye and stay safe.